Hi students, I hope you are doing well. Okay, so today we are back with a new chapter, circles. Okay, circles is a very important chapter in the 10th standard. You might have studied circles in the 9th standard also, but in 10th standard you have two theorems based on circles. Okay, and those two theorems are also very important. Means among these two, one you can expect for exam. One definitely. One theorem will be there for your exam. Okay, and also here, especially this circle topic you might have come across in ninth, as I said before. So before going to the topic, I'll just recap what exactly a circle and what are the different like tangent, the secant, uh, and chord. What are these? You might have studied in the ninth also. Just I'm just like recapping those concepts once again. What is a circle? See, basically, I hope you can see this. Circle is, we draw the circle like this, right? And this we call it as center, and this we call it as radius, and this total length we call it as diameter. Okay, I hope you can see this. So circle is basically a round shaped thing. It may be like you might have seen a bangle, which is a like shape of a circle, a 1 rupee coin which is in the shape of a circle. Those are the examples. So what is the circle geometrically? What do you mean by a circle? Okay, according to geometry, how can you define a circle? Remember, a circle is nothing but it is a figure, or it is nothing but it is the locus of all the points. Let me explain clearly with the definition. Okay, a circle is nothing but, for example, we will just, this is a plane. Imagine that nothing is there here. There is a plane, and here we have one point, just a dot. Okay, I just draw some points. It's just a rough diagram. Don't go in practical way. It's a rough diagram. See here, if you draw some points, okay, these points will make exact same distance. See, with respect to this point, these points are making same distance. For example, if this is 2 meter, 2 centimeters, this is also 2 centimeters, this is also 2 centimeters, this point also 2 centimeters, and this point also 2 centimeters. When you join all these points, you will get a circle. Correct? So what do you understand from this? Okay, circle is nothing but it is the path of all the points joined with respect to the center. Correct? See, this we don't know before it was center. Now it is the center. It means I draw one point. I'll just repeat once again to you guys. I just randomly draw one point. You can draw anywhere in this plane. Okay, and I just drawn some points which are making same distance. See, this this is making 2 centimeters. This point also should make 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters, 2 centimeters. So you draw one line, like one line joining all this. Okay, so it will form a circle, isn't it? Just an example I am giving. So this is also 2 centimeters. This length also 2 centimeters. Every length or the line which you drawn, which is 2 centimeters. Correct? Basically, what is a circle? It is the locus. We call it as this path, or the path of all the points joined. Okay, and those points should make the same distance with respect to the point. One point, that is the center. So this is called center of a circle, and these are the points of the circle. You can draw infinite points. Infinite points you can draw. So it is nothing but the joining of all the points which are making same distance with respect to the point which is called O here. We'll take this as O. The point O. So that particular figure or that particular geometrical figure formed is considered as a circle. See, this is maybe not required for your, like exam, but you should know what exactly a circle is. So what is a circle? It is nothing but a geometrical figure formed by the points drawn Okay, and those points which will make with respect to the bow, the same distance they will make with respect to. So that is the joining, whatever the like figure formed by the joining of all the points we consider as a circle. Okay. Now, I hope you understood this. It's very simple. With respect to the point O, we drawn some points. These points are making some same distance, 2 centimeters, 2 centimeters, 2 centimeters. See here one point. Okay, let me write it. P, Q, R, S. So these are the 4 points are there. With respect to O, they are making same distance. So those points I joined. Correct? So I got a shape. That shape, whatever the figure you got, that is considered as a circle. I hope you understood. Now, what is basically tangent? Okay, there are 3 concepts you have to learn here. One is tangent, secant, chord. Okay, tangent, secant, and chord. So let me explain what is a tangent. See, first let me go with tangent. Before that, you should know this is a center, correct? And basic things I hope you know. This is called radius, and this total we call it as diameter, correct? So what is diameter? The length between, see, remember, this is called diameter, correct? So diameter is always 2 times of radius, correct? Diameter is always 2 times of radius. That you might be knowing it from the last classes we discussed. Okay, in 9th standard also you might have went through that. Diameter is nothing but 2 times of its radius. What is the radius? This is called radius. It means from center to any point on the circle, if you draw a perpendicular, that is called your radius. Anyway, okay, from here to here, you can here to here, here to here, anywhere you draw, it will be considered as radius. Okay, so you can draw a circle, okay, with radius, correct? How do you draw a circle? You just take compass and you measure the radius. They will give radius only, correct? If they give diameter, you have to divide by 2 and you will make it radius, and with that radius only you will draw a circle. It means what? Everywhere, anywhere in this, you randomly you take a point and measure from that point to the center of the circle. That is called as radius, and that should be same throughout the circle, correct? So that is radius, and the double 2 times of radius is your diameter, correct? So next, what is called? Let me go with chord first. C-H-O-R-D. What is chord? Chord is nothing but, for example, if you consider this circle, okay, with center O, let me consider 2 points A and B here. Okay, see, you have to take the points that should lie on the circle. You cannot take the point here or somewhere outside the circle or not even inside the circle. You have to consider the 2 points or assume 2 points or locate 2 points on the circle and just join those 2 points. This line segment formed by joining those 2 points which are there on the circle, that is called as chord. Okay, this you can name it as chord. Correct? So remember, diameter is the longest chord. Diameter is considered as longest chord. Okay, diameter is the only the chord which is the longest chord present in the circle, or you can draw to a circle. Understood? Okay, whatever the other chords you draw that are like lesser than diameter. Okay, that you have to remember. Okay. Now, what is secant? Secant is nothing but, now we are writing this, you take it as CD, correct? Then what is secant? Secant, there is a confusion between secant and chord. Usually, students will confuse. Secant is a line. For example, if I draw, for example, a line like this, which will pass through the points E and F. See, again, E and F are the points which are on the circle, correct? And we are drawing a line which passes through the, point E and F. This line is called what is the secant? Okay, so difference is what between secant and this chord. Chord is a line segment, whereas secant is a line joining 2 points on the circle. Okay, I hope you understood. So a chord is the line segment which joins A and B. For example, 2 points on a circle. Again, EF you see. EF for the line, same. The difference is this is a line segment and the secant is a line. Okay, a line joining 2 points on a circle. Okay, which is considered a secant. A line segment joining 2 points on a circle is called chord. Correct? Remember 2 points, not 1 point. So now this definitely you can you can just imagine or you can assume or you can see here the chord CD, okay, divides the circle into 2 parts. Correct? Chord CD, if you see the chord, as I told, diameter is the biggest chord or the longest chord. So that longest chord CD divides the circle into 2 parts. It is not only CD, even AB you see. This is one part and the other thing is another part. Correct? So this chord always divides the circle into 2 parts. If it is a diameter, then as I said you, the diameter is the longest chord. Always diameter will divide the circle into 2 equal parts. It means you can write like this. Just an example. This is one part and this is another part. Correct? This will happen only with this is possible only with the diameter. So diameter is considered as the longest chord. You can take any other chord on the circle, you cannot divide the circle into half apart from diameter. So diameter is the only chord which can divide the circle into 2 equal parts. Okay. Now I hope you understood what is a secant and what is a chord. And now we will come back to the concept of tangent. Then what is the tangent? Okay. Tangent is the line. Okay. For example, let me take a circle. Okay. Again, with center O. Okay. I'm just with a rough figure. Center O I'll take. Okay. Now let me consider one line here. Okay. See how? What is the difference between chord and the tangent? You can observe that line that is touching the circle. It is not intersecting the circle. Very, very important thing you should keep in your mind that the tangent will never intersect the circle. Okay? Understood? It will never intersect the circle which touches the circle. For example, there is a point A over there and we draw a line which touches the circle at point A. So that is called as tangent. So, Carl, what is the difference? If, for example, if this is there inside like this, little inside, okay, then you see here, this touches the circle at 2 different points, not 1 point. Understood? Then that is called as secant. That is not a chord. So, that is not a, tangent. So, remember, tangent is nothing but, what is a tangent? A tangent is a line which touches the circle at one particular point. You can draw how many tangents you want. You can draw here one more tangent, which you can name it as some C here, you can name it as B here, anywhere. Okay, but one thing you have to remember, okay, or you can take in order also. So, what I am trying to say, at one point, you can draw only one tangent. It means at the point A, you cannot draw one more tangent. It is not possible. If you draw, it will become a secant or some other thing, whatever it is. So, at one particular point on a circle, you can draw only one tangent. Okay? It means at one point on a circle, you can draw only one and only one tangent is possible. You cannot draw more than one tangent. Okay? I hope you understood. I will just revise for tangent especially. Tangent is the line which touches the circle at one particular point. Tangent is the line which touches the circle at one particular point. Okay? And you can draw only one, like tangent at one particular point. You cannot draw more than one. Because if you try to draw it, it will become some other thing. It may become secant. Correct? Now, and one more thing you have to understand. How many tangents you will be having a doubt? How many tangents we can draw? You can draw infinite number of tangents. Because why infinite number of tangents on a circle? You can draw many points will form a circle, right? as I said you like this, like if you draw so many points, infinite points you can draw here, anywhere you can draw. So you cannot tell how many points it is. How many tangents also it is not countable. You can draw infinite number of tangents with infinite number of points. So that you can, I hope you understood the difference and what is a tangent and what is a secant and what is a chord. Okay, and one more important thing you have to understand. Okay, let me write and show it to you. Before like starting this theorem, you should know this. Okay, see how this is the center if I assume. What is the shortest distance which we can write? See, this you can draw this like this, you can draw like this, you can draw this, we can take as A, this you can take as B, C, D. See, this is the shortest distance you can draw anywhere in the circle. Understood? On the for any point on the circle. For example, I considered A on the circle. So this is the distance, and OB is the distance. OC is the distance. OD is the distance. Let me consider one point, okay, outside the circle. Okay. For example, if I consider here, okay. So if you draw one, like line here, distance. Okay, imagine that before that I'll draw one tangent on the anyway that I'll explain the theorem. Okay, so on the this A, the line A should touch the circle as well as should touch the tangent. What I did, I drawn a tangent at the point A. This point A which touches the circle as well as the tangent. Correct? This tangent also it touches is a common point which touches both. So if I draw one more point here and I'll just locate, I draw one more point B, I locate one point B and just I join OB. So look at this, OB is always greater than OE. You can draw infinite number of points like this, OB, or if you draw very nearer to A, even this is, take it as C, and this length is greater than OA. Okay, and always remember this shortest distance is always perpendicular. Correct? Understood? Okay, see OC is not perpendicular, OB is not perpendicular. Always the shortest distance drawn on a tangent with respect to the center of the circle is always shortest distance, and it is a perpendicular. It means what? A line drawn from the center to a tangent is always perpendicular to the tangent, and it is the shortest distance. Why it is perpendicular? Because it is a shortest distance. So that is the reason shortest distance is always perpendicular. Anyway, I'll explain this in the theorem also. And one more example I will give you. Right triangle is that. See how? This is called hypotenuse and this is called the, what is it? Distance, right? Always you see, this you take it as A, B, C, correct? So AC is the longest side compared to AB. So which is the shortest distance? In this triangle ABC, AB is the shortest distance and AC is the longest distance. Okay? If, because why it is shorter? Because it's a perpendicular to the line BC. Correct? That is the reason AB is the shortest distance compared to AC. Why AC is not shortest distance? Because AC is not a perpendicular. It is making some 60-degree angle, or it may be making some other degree angle. I'm just giving an example. So if it makes 90 degrees with the line, for any figure, just I explained you with respect to triangle, you can understand. In any figure, it may be in a triangle, or it may be in a like rectangle, or it may be in any circle or in triangle. This, imagine that BC is one line segment or line. So when you draw a perpendicular and when you draw one more line which is not a perpendicular. See, B is one point on this line. Imagine this is a line. Okay, this B is a point on a line. This will take it as from L, line L. Okay, this P is a point on the line L. Okay, and this is JB is a perpendicular and C is a point on the line which is not a perpendicular to it. Correct. So remember, AB is the shortest distance or AC is the shortest distance. So we will say AB is the shortest distance. See the distance measurement. This is less than this, of course. So AB is the shortest distance. Always remember, a perpendicular is always shortest distance which will make with respect to any line, with respect to any figure. Always see shortest distances or shortest line is always perpendicular to the tangent. Okay, understood? Perpendicular to the tangent. Always remember this. The shortest, this you just keep this in your mind. The shortest distance, okay, is always perpendicular. Shortest distance with respect to, especially with respect to tangent drawn, is always perpendicular. I'll just explain this triangle example. Don't know how many of you understood. So, for example, let me take this triangle and draw a tangent. I don't know whether this is. I'm just giving an example. Don't take it to like a geometrical way. A, B, C. So this BC is basically what we are drawing one perpendicular here. Line I drawn which touches B and C both. Okay. So this C is there on the line. B is there on the line also. Both B and C are there on the line L. Both the points are there. But which is perpendicular? AB is perpendicular. So AB is the shortest distance, not AC. That is only I am trying to clear you. Okay, which will make perpendicular distance with respect to this line is shortest distance, whereas AC is the longest distance. And always remember the shortest distance is perpendicular to with respect to that line. Just AB is perpendicular to it. Okay, anyway, that is the basic thing which you should know. That's why I explained, I stress so much, okay, on it. So let me explain the theorem. Okay, see, it is very simple, guys. Always remember a perpendicular line is always make a shortest distance. Okay, that's the thing which you have to understand. So now let me explain the theorem. Theorem, as I told, very important. These two theorems are there. This is one and one more also is there. These are very important with respect to your examination or with respect to your examination point of view. Okay. First, let me go with the statement. See, in exam they will give the statements. Don't worry about it. They will give the statement. You have to just prove it. Okay, you have to prove. So, what is the statement given? The tangent at any point on a circle is perpendicular to the radius through the point of contact. The tangent drawn at any point. See, tangent at any point on a circle is perpendicular to the point of contact, radius through the point of contact. It means what? We have to prove that this line drawn through the radius. See, this is the radius, right? So OP is the radius. So what is the statement meaning? We have to prove, see, the point drawn in a tangent. See, for example, XY is the tangent we have taken to the circle. Correct? The center O. So with respect to radius, I am drawing a line. Correct? This is the radius. So OP is the radius. So this OP, whichever I drawn OP, that line segment OP should be always perpendicular to this tangent XY. So what we have to prove? We have to prove OP is perpendicular to XY. That is the statement actually. So I'll repeat the statement. The tangent at any point on a circle is perpendicular to the radius to the point of contact. It means tangent drawn with respect to radius at any point on the like circle, okay, which is perpendicular to that. What is it? Perpendicular to the circle through the point of contact. Okay, that is only there. They are trying to can make you understand the statement. Basically, we have to understand what we have to prove. OP. I'll just show you with the figures. OP is the line which is drawn through the radius. That should be perpendicular. We have to prove this is perpendicular with respect to the tangent XY. Okay. First, construction. What is the construction we are doing here? Draw a circle with center O. Correct? We draw a circle. It's very simple theorem. And draw a tangent XY. First, you have to draw a circle with respect to O. Correct? Take O as center and draw a circle and draw a tangent XY. Okay? And remember, this tangent XY touches the circle and the tangent at P. So P is the point of contact. That is the whole right point of contact. What is the point of contact? P is the point of contact. So you draw a tangent XY through P. Correct? So now, yeah, this is the construction part. What is that? Draw a circle with center O and draw a tangent XY which touches the point P at the circle. Correct? The P touches the circle as well as the line tangent. Correct? tangent xy. So this is the construction problem. Then what we have to prove? We have to prove this OP, the line or the line segment OP is perpendicular to the what is the tangent xy. That is the proof we have to do. So to prove you right. Proof. Here to prove that it's very simple. The proof is very simple. Draw a point Q1 xy. See, we can draw more than Q, anything like this. Q1 also I'll draw. Q2 I can draw. Okay, this you take Q1, Q2, put dotted lines. Actually, it is not required to show. I'm just giving an example to show. You can write Q3, any lines you can draw. Always remember, we just draw a point Q1, Q1, like even you can draw Q1, Q2, etc. Any, how many, n number of points you can draw. Okay, so whichever you check, whichever the point you check, the line, the distance between OQ1 and distance between OQ2, OQ3, any distance you compare with the distance OP, they are greater. By looking at this, like lines only, line segments only, you can confirm, right? OQ is OP greater than OP, and OQ2 is greater than OP. OQ3 is, you can even take the point very near to P. That I will take it as Q4. Even this OQ4 is greater than OP. It means what we can prove, OP is the shortest line compared to the lines OQ4, OQ1, OQ2, OQ3, OQ4, any number, any line you take, OQ4, OQ1, OQ2, OQ3, compared to the distance between O1Q4, O1Q, O1Q2, O1Q3, OP is the shortest distance and that is the shortest line. Correct. So if always, just now I explained you, always the shortest line or the shortest line segment will be perpendicular to the line or line drawn or the tangent. Always remember the line which is line segment which is making the shortest distance with respect to the tangent, okay, that will be perpendicular to the tangent. Okay, it is geometrically also you can easily see that I drawn around 4 or 5 points apart from P and they are on the line segment. They are not touching the, like tangent and the circle. See, this P is the common point which touches the circle and the tangent also. So these are only touching the tangents and we drawn the line and check. But we drew and check, but those distances are always, we found out they are the larger distances compared to OP. So OP is the shortest line and which will make the shortest distance. Always remember the shortest distance, okay, is always perpendicular to the line. Understood? As I explained with the triangle also, okay. Shortest line, shortest distance is only perpendicular. That's why I told this again. I don't want to say it once again with respect to triangle. So always remember the shortest distance which will make the shortest line is always perpendicular. So that is the reason we proved OP is perpendicular to XY. That's all, hence proved. Okay. One thing you remember is when you prove that OP as the shortest line, your 90% of your theorem proof is done. When you prove that any line, here OP is the shortest line, anything which is shorter compared to the other distances, that should be perpendicular. Okay. Fine, I'll just explain you once again. What this theorem we have to prove, the tangent at any point in a circle is perpendicular to the radius through the point of contact. Tangent at any point on the circle. It is not only here, you can even draw here also. Yeah, that is only that telling. If you draw here and draw one line here which passes through the point of contact. So it means what? I drawn a point tangent here, which at which point I draw a tangent Q, and I drawn a line which passes through the point of contact. From where I draw a line? I draw through the radius. Correct? I draw a line through the point of contact. So if you write 1 Q, if you join, that will become a radius. So that is the meaning here. The tangent at any point on a circle, the tangent at any point on a circle is perpendicular to the radius. Okay, this tangent is perpendicular to the radius. See, this tangent is making 90 degrees with the radius. So That only we are going to prove. Okay, a tangent at any point on the circle is perpendicular to the radius through the point of contact. So very important thing, through the point of contact. Only it is perpendicular through the point of contact, not any point which is not a point of contact. See, this is not a point of contact. So if you draw one line here and take it as q dash, and if you draw this line, that is not perpendicular to the, and this line are not perpendicular, tangent are not perpendicular. Only this happens when you draw a line, okay, through the point of contact. Okay, I'll explain once again. A tangent at any point on a circle, a tangent, we draw a tangent at one point P, any point you can take. I've taken here P, I've taken Q here. Okay, a tangent at any point on a circle is perpendicular to the radius of the circle through the point of contact. So this OQ and this line is perpendicular only when it is passing through. It should be a tangent and this point of contact. Point of contact means that this point is the point which is touches the circle also, which touches the tangent also. Okay, as I told you that tangent is possible for a circle only at one particular point. That is called as point of contact. For example, if I draw here a circle and I draw one tangent like this, this is the point of contact, and this is the point of contact. And this, if you draw here, this will be the point of contact. And this, if you draw a radius here, and this radius and this tangent is perpendicular only at R, at that particular point, which is called point of contact. Okay, I explained clearly, I hope. So draw a circle. What is the construction what we are doing? We are drawing a circle, okay, the center O, and again we drawn a, what is the tangent xy? I'll just remove this, which is only for your understanding I wrote. Okay. Okay. So draw a circle with center O and draw a tangent xy which touches the point P at the circle. So we draw a tangent xy and this tangent touches the circle at the point P. So next, to prove, what we have to prove? We have to prove that OP is perpendicular to the tangent xy. Next, what is the proof we are doing? Proof is very simple. What we are doing? We are drawing a point Q. I just draw a point Q on xy, which is not the point of contact. Obviously, there will be only one point of contact for a tangent of the circle. So apart from that, I draw one more point, which is Q. So these are only the examples I written. You don't write it. Only you can just write Q, enough. These are not required. Okay, fine. This is only for making you understood. I written only 2 are enough. Okay, so yeah, we draw a point Q, and you can draw not only Q, you can draw Q1, Q2, Q3. Apart from point, you can draw any number of lines on the tangent. So if you just check the distance between those points, like O to Q, that the distance between center to that points, OQ, OQ2, OQ3, OQ1, any point you take, always the distance is greater than OP. You can see it and tell. OQ is always greater than OP. Correct. So it means what? OP is only the shortest distance. Okay. For the tangent, OP is the only shortest distance. So always remember, shortest distance is perpendicular. Now hence we can say that, therefore OP is perpendicular to xy. So shortest distance is always perpendicular. Okay. So basically what you have to understand, when you are able to prove that OP has a shortest distance, then your 90% of theorem you prove. When always remember, shortest line or shortest distance is always perpendicular. So that is the reason OP is perpendicular to xy. I hope you understood this clearly. Okay, and very important theorem. Yes. Thank you very much. Okay, please like, share, comment, and subscribe to our channel. Please support us. Have a great day.